Okay, lesson 65 is adding radical expressions, and then another thing after that called weighted average. Now, the biggest thing we need to learn about radical expressions, well, here's what one looks like, a radical expression. They usually are listed out like that, and we can see if there's any way to simplify it. Now, radical expressions behave like terms, okay? So pretend like this here on example 1. Let's say that said 4x minus 5x plus 12x. How many x's would that be? Would that be -1 plus 12 would be 11x. Okay. When you have the same number under the radical, they behave like terms. Okay. Now, if they weren't all 2's, then they would be different. They would not be like terms. Okay, we'll do that on example 2. So example 1, instead of x's, we have 4 root 2's, 5 root 2's. So if we subtract those, then you get -1 root 2 plus 12 root 2. And put those together, and we have 11 root 2. And that is it simplified. Okay, I am messing with exposure on this one, so it seems to me that the paper is looking a little red, so I might change that. I did auto ISO, and it's kind of changed things, so I'm learning as I go on the best videography, so bear with me. All right, example 3 now has 2 like terms and 1 unlike, not like, all right? So that means only these 2 can join up. And so I have a +4 root 3 and a -6 root 3. So what that is -2 root 3 plus 3 root 5, because he had no one to join up with. He did not have any like terms. Or she. Sorry, I call a lot of my terms he. I like to give them personality. Okay, example 3, moving right along. We've got 4 items there. Let's see right away, do I see any like terms? All right, looks like these 2 get to pair up and these 2 get to pair up. All right, and then once we're done with that, there's nothing else we can do. So I got a -3 root 2 and a -2 root 2, so together that makes -5 root 2. Okay, and then 5 root 3 plus 8 root 3 is plus 13 root 3. And there we go. That is the final answer. So I like to do a nice, beautiful box to show that we're done and we're secure and feel confident about that answer. A box always shows confidence, so good job. All right, let's look at example 4. All right, well, I'm also seeing in all these videos, I say all right or okay way too often. It's driving me nuts, so I apologize for that. I will work on that. We have 4 root 3 minus 2 root 2 minus 6 root 5. Now, I'm noticing none of those are like terms. So at first, that's kind of frustrating because we like things to be able to simplify and pair up, but not going to happen. So look what I get to do. And we get to do that with confidence. Box that answer. The good news is you didn't have to draw or do any calculating. Okay. See, I said it again. Okay. And I say a lot too. Working on that stuff. Sorry, gang. We've done radical expressions, and now we're going to talk about this thing called weighted average. Now, most of you have been affected by weighted averages. In fact, everyone in my algebra class, because I weight your problems or your assignments differently. I give your tests more points than your quizzes, and your quizzes more value than your homework assignments. So how you do in my class is affected by what's called a weighted average. Okay, so we've got an example here. We've got Matthew. His score improved on each test. Good job, Matthew. We like improvement. It looks like he started out with a 60, and we're going to assume these are percents. So he had a 60, a 71, and a 91. All right, good job by the end. That looks like that would be in the A range. Okay, that's good. Now, the average, the normal average of his test scores, remember how if we just did basic average like you're all good at, we would just add up those 3 test scores, divide by how many of them there were, 3, and look at me, I calculated it for you. So did the book if you look at the book. All right, so we put that together, we got 222 over 3, which when you divide that, 74. All right, not bad, Matthew, but what if your teacher thought, this will say it in the next page, the teacher thinks that maybe the most recent test scores are actually more valuable. They meant more to her. I don't know why, but we will see. The teacher didn't think it was fair, as you're reading in your notes, because she thought that the second test was twice as important as the first test, and the third test was 4 times as important. So she is going to create a weighted average for Matthew. So that's actually good news for Matthew, because his average will go up because she thought the last one was most important, and thankfully the last one is the one he did the best on. So this really worked in his favor. He must be friends with the teacher. She must really like Matthew and maybe had a heart for him on those last couple tests. Teachers always love to see improvement. So if you start out a little rough, we love to see improvement. All right, so here we are. Another way to, so here's what we would do. Weighted average. Like we said, the first test was 60. Then she said the second test was twice as important as the first. So she put 2 71s in there. And then the last test was 4 times as important. So 1, 91, 2, 3, and 4. So now we have 1, 2, 3, 4, 5, 6, 7 test scores that we are averaging. Divide by 7, we get 566 divided by 7, comes out to an 80.86%. So that helps a lot. Now I'm going to show you this equation just simplified down. That looks like this. There was one 60% test. This one was weighted double, so it's 2 times 71. And this one is weighted times 4, or quadrupled, the 91 was. So if we notice that what's in the parentheses there gets to come down here, and we have 7 again. So notice those are the same, just slightly different. This is a simplified equation, doing the exact same thing, and 80.86. Good job, Matthew. That is great. All right, in example 5, we have McKenna. McKenna got some scores. She had a 60, a 70, an 80, and a 90. Just goes up. Again, we love improvement. Good job. What is the weighted average of her scores if the tests were weighted 1, 2, 3, and 6 in that order? What they're saying is 60 was weighted 1, 70 was weighted 2, 80 was weighted 3, and 90 was weighted 6. Ooh, she really beefed up that 90. Give it a lot of weight. So that's good. Again, this will work in McKenna's favor. So let's go ahead and take what we know and put that into our simplified equation. Remember what we put in the parentheses here? So we're going to take the 60% that she got. Oops. I'm trying to remember how I do that. Okay, either way, we can put the 60 on the outside or put 1 times 60, and then our 70s, and then our 80s, and then our 90s. Okay? And 60 was worth 1, 70 was weighted double, 80 was weighted by 3, and 90 was weighted by 6. That is good news. And now if we add 1 plus 2, so I'll write it so you can see 1 plus 2 plus 3 plus 6. All right? And I'm going to use my calculator. It's in the book, but I don't have the book with me as I'm doing this with you. So I'm going to have to calculate this out quickly while you're waiting patiently. And I'm not going to calculate the bottom. Please tell me that you also would know that this would be 12. Okay, so the bottom is 12. It's going to take a little more time for me to do, let's see, 60 times 90 is 540. Okay, 6 times 9 is 54. Add the 0. Plus 3 times 80, which is 240. Plus 140. Plus 60. Okay, and my calculator gives me 980 over 12. Now you might check in your book and see if I made a mistake. I'm double checking. I always like to do that, especially on tests class. So let's see, I got 980 again over 12. And then if we divided those, we get an 81. Well, actually, I'll show you. Here's my calculator. Oh, can you see? It's a little dark in here today. Oh, it doesn't even want to show. Anyway, it says 81.6666666. Okay. So a lot of you guys, so basically in my calculator display it says 81.666 ... It just keeps going, right? So we know, actually then it goes to a 7. I do want to talk about this calculator display here, because I see a lot of people decide when they want to round that, they just cut off the back end, and we can't do that. So I went to above, they rounded to the nearest hundredth, so we'll do that as well. So I can't just cut off the rest of the group. I have to look at this one and see that that is bigger, is a 5 or bigger, so it's going to affect this one. So it's going to be 81.67. So good job, McKenna. That last 90, set of 90 really helped you. The last example is about Jordan. Maybe the Jordan in your class, but maybe not. I think the Jordan in your class will probably do better on her scores when she's in grad school, one can hope. But this is just a hypothetical that I stole from the book. In the graduate level course Jordan was taking, each of the 3 tests were weighted 20%, and the final paper was weighed 40%. Jordan's scores on the 3 tests, 3 tests were 60%, 70%, and 80%, and her score on the final paper was 60%. What was Jordan's overall score for her course? Well, these are all a bunch of percent, so all we're going to do is change percents into decimals. Okay, so we're going to say average. Be good to spell average correctly. I feel like maybe I'm a little shaken because I don't have the book with me, so I have no way to confirm that I'm doing the calculating right while I'm on tape. So here we are, weighted average. She has 3 tests and a final paper. So we're going to have 4 things up here. Her 3 tests were weighted 20%. So what we do is write 0.2, and her first test was 60%. Then her next test was 70%. Then her next test was, whoops, plus a plus a plus. Her next test is 80. And the last final paper was worth more, and it was worth 40%. So I had to go back and look. It was worth 40, and there we go. Now, we do want you to notice that when you add up all the weights, it should, and you're dealing with percents, they should total up to one whole. So 0.2 plus 0.2 plus 0.2 is 0.6, plus 0.4 is a whole. So when we add up all the percents, we should get one whole. So we have that correct. All right, when we add up all the weighted percents, not necessarily her test scores. Now we have, well, since we've done that, we are going to add those all up. Now we divide, like I said though, all of these add up, whoops, all of these are going to add up to one whole. So honestly, when we're dealing with this part is a little extraneous, but I'm going to do it for fun anyway, just to make a point. So if we add all those up, I'm going to put my answer down here. Okay, we 0.2 times 0.6, 0.2 times 0.7, 0.2, etc. We're going to end up with 0.66 over 1, which really is 0.66, which is 66%. And that's her average scores. Like I said, I think the real Jordan, who might have her name in here, would probably do a lot better. This is more of her evil twin who slept in on the test day and maybe slept through writing her final paper. I think she'll do a lot better. So I hope that all makes sense. You have some practices with the radicals, simplifying radicals, and then one weighted test score example. So that will be it for lesson 65.